Hello, this is the project log for my final project for the course Object-Oriented Programming. And this project log has to talk about what my progress has been so far. And I have to explain my so far implementation of the project. So far, me and my partner Hania Sultan have decided on how we will be implementing this project, which is a game. A little background overview of what object-oriented programming is. As we know that data can be anything uh, such as a number or a word. These things can be classified, a picture, these things can be classified as data. So as we know that in order to achieve a deep, like a complicated program, in order to implement a complicated program, we have to do a lot of operations, and one of those operations is grouping a certain types of data together. So that is the concept of object-oriented programming, or more commonly known as OOP. OOP is just the grouping together of data, and yeah, so in our language, which is C++, we will, the types of data for a number can be an integer, float, or double. And the type of data used for a word can be a string. So in our scenario, these are the two data types, or there can be various other data types as well, but I'm just going to be talking about these two right here. So object-oriented programming, mainly the idea behind OOP is that you group various type of data together, and then when and then that would be like that you are grouping these data together and you are creating another data type out of it, another entity, and that entity would also be having its functions that it can perform on its data or any other data that is passed to it as a parameter. Uh, so this function is called the method of that group of data. This group of data is called a class. It's like a blueprint, and any group of data made through this blueprint is called an object. And the function and the all of the each element of the of of the class, which is a type of data in its own, for example an integer or a string, are called the attributes. So this is just a little breakdown of what OOP is supposed to be like. Th- there are four pillars of OOP, or more common, or in other words, or simpler. Wait a minute. So as I was saying, there are four basic concepts of OOP, and they are called encapsulation, abstraction, inheritance, and polymorphism. I'm not going to be talking about these as they are a few deep concepts, and I haven't decided what the code that I will write for this game, which part of that code will be having what pillar. I haven't decided that so far. But I have decided what classes, what object, what attributes of those classes and what methods of the classes will my game be having. This is very tentative. So to talk about my game, I will be breaking this into another video. So I will be pausing this right here and I will be going to the other video. So this is the part two of the same progress log that I was describing in the first video. You are going to be seeing both of the parts as one single video. So it would be a bit confusing, but please bear with me. So the part two of this video just is intended to tell you about how I'll be implementing and what classes I'll be implementing in my game and what my game mechanic would be looking like. So uh, my game would be using C++ to define everything that the game would be having, every mechanic. And using that mechanic, a game engine, SDL, will be creating animations while using those mechanics and achieve the functionality of a game. A game engine essentially does what I just described to you as it takes mechanics from a file and it reads its own code which is essentially telling the as like the game engine how to how to create those animations using those mechanics and how to display it to the user. This is essentially the work of a game engine. I am going to be using the SDL library game engine for my project, and the programming language that I'll be using to define the mechanics of my game will be C++. And I will be using the concepts of object-oriented programming. This game is supposed to be looking like Mario, and the essence of this game is that there will be a vampire characters with 3 lives initially, and it has to navigate through obstacles, and it has to collect bat to secure victory. Inspiration is from Subway Surfers and Mario. So the mechanic is that there will be a time-based challenge. There will be a timer going on in the top right corner of this game screen. And before the timer ends, the vampire has to collect a specific number of bats. The vampire character continuously advances towards the right, and it has to collect the bat before the timer runs out, and it has to maintain at least 1 life to win this 3 life what I was talking about. It has to maintain at least one to continue playing the game. If all the lives end, the player is going to lose. Player has control over the vampire movements. Uh, these movements will be defined by the W key, A key, and D key. A key will be allowing the vampire to move towards the left. The D key will be allowing the vampire to move toward the right, and W key will be allowing the vampire to move to jump. I am not defining a behavior for the S key because we are not intending the vampire to duck while going towards any position. This is a functionality of Mario. We are not going to do that here. Not Mario, Subway Surfers, but we are not going to do here. So the so the vampire moves right. We have the control of vampire movement. We also have this concept of abilities where the vampire can use abilities that they have collected, and they can use those abilities to avoid obstacles. Contact with obstacles will result in the loss of a life of the vampire, but collecting jar of blood will add extra count of the vampire's life count. So the obstacles that I was talking about right here, which will result in a loss of life, are inspired from the classic tropes of vampire lore. These obstacles are like onion, garlic, and silver cutlery and pesky cats. these obstacles right here are have a special feature to it that when that for example, this is our game screen that and the vampire is right here. Whenever these obstacles will be coming towards the vampire, these obstacles will be originating from the right bottom corner of the screen, but they won't be originating just instantly and out of nowhere. These just the three of these obstacles uh, are going to appear only after a human appears here for 1 or 2 frame and places the and does an animation that places the obstacles for the vampire character uh uh to kill the vampire character. This is just a silly feature to add to the lore of the game. So these obstacles pose increasing difficulty as the game progresses, keeping player on their toes. Now there is a concept of power up that we talked about right here, the use of abilities. These power ups include abilities like flight, uh, like the jetpack in Subway Surfer, laser eyes, destroyed all objects in the visible frame, the obstacles in the visible frame, freezing time, which pauses the timer for a few seconds, and jar of blood, which increase their lives. All of these power-ups are collected as game proceeds by vampire characters. Some of these power-ups, when collected, do not activate instantly, but rather are activated by the player. For example, fly and laser. Uh, so this is something like how hoverboards are used in Subway Surfer. When you double tap, the hoverboard is activated. Similarly, when I will be pressing the F key, if my vampire has collected a fly power up prior to activate prior to pressing the F key, the vampire will be able to fly and avoid all obstacles. And prior to pressing the L key, if my vampire has collected the laser power up, and laser power up is available for a vampire to use, the vampire will be able to use the laser power up, which will essentially destroy all the obstacles in the visible frame. There are other obstacles which are activated as soon as they're collected, much like the what do you call it? The jetpack in Subway Surfer. That when you collect a jetpack, it activates instantly instead of giving the player the ability to activate it. As described earlier, there is a score point system that the player has to collect certain bats in a given time frame. This is my UML diagram of what classes and what attributes of those classes and what methods of the classes I'll be using. This portion of the game description document tells us of describes the graphics of the game to us. We will be having just one window, which is going to be 1000 by 1000 in pixel. On that window, there are going to be two available screens: a start screen and a game screen. Both of the screens will be in the 1000 by 1000 uh, pixel dimension window. So both screens will be having this dimension only. And in the start screen, I will be having the button to start the game and increase or decrease the difficulty level of the game. In my game screen, whenever I start the game, I will have a number of lives remaining counter at the top, an indicator if laser eyes is available to use below that, and the indicator if fly ability to use is available to use below that. The score, the total number of bats collected out of how many are remaining to be collected on the top right corner, the option to restart the game below that, and the option to quit the game below that. Moving forward, The vampire character star can only move a cannot move in this entire 1,000 pixel frame. The vampire character can only move between the pixel 300 from the right of the bottom left corner and pixel 300 left from the bottom right corner. The reason for that is that whenever we are trying to show that the vampire is moving along the level and he is unraveling of what is unraveling the part of the level that is yet to be discovered, the vampire has to move right. But if we were to show that the vampire goes to this pixel right here, and then the remaining of the level is starting to unravel, the obstacles will come and start to hurt vampire uh, as they appear, which would produce glitches in our game. We don't want that. So as soon as vampire hit goes right and hits this point right here, the flooring starts to move on the left, which essentially creates an effect that vampire is moving forward towards the level. This might not be even 300. This might just be till 400 or something. And the same effect is used right here if vampire has to go back of the level which he has already discovered and unraveled. He just needs to go left till the 300 or 400 pixel value and the floor will start moving right, essentially creating an effect that the vampire is moving backwards in the level. This description is essentially what I explain in these 2 points and this point as well. Below are a few images that show what our game screen will look like, and these images also include the collectibles that vampire collect, be it uh, collectibles and obstacles. Both of these things will be 150 by 150 in dimension. This is the game screen, and this is what the game screen will look like, and this is what the uh, welcome screen will look like. This is what the collectible bad score point will look like. This is what the collectible flyability will look like. This is the collectible laser eyes. This is the collectible freeze time. This is the collectible blood jar. This is the obstacle garlic, obstacle onion, obstacle cutlery, and obstacle cat. So essentially, this was what my uh, game, ho- the game Hotel Transylvania Adventure and its description. I hope you enjoyed. Thank you so much for watching. Allah Hafiz.